Hi, Mr. Causey here. Here's a couple of vectors u and v. We're asked to find the dot or scalar product. The way we do that is to take each of the components. There's components of u, or -1, 4, -3, x, y, z components, and multiply them by the corresponding components in the second vector, and then add the results. So we've got -1 times -6, times -7, plus 4 times 8, plus -3 times 5. So that comes to 7, 32, -15. So it's 39 minus 15. 24. Now let's have a look at the second part of the question. We have to calculate the acute angle between u and v. Now in your exam you have a formula sheet where you're given a couple of different ways of working out the dot product. The one we've just used in part A was the second method, where you've got all the coordinates, all the components, and you do this multiplication across and add the results, which we got 24 for. There is another way of finding the dot products, and it's this. It's the length of A times length of B times the cosine of theta, where theta is the angle between each of these. Now, it is possible to rearrange that formula and get cos theta on its own, and you'd do that by dividing both sides by the length of A times the length of B to get cos theta on its own. So that gives us a formula for finding the cosine of the angle between two vectors, and it's the dot product, which we've already worked out, divided by the product of the two lengths. So in this case, cos theta is u dot v over the length of u times the length of v. So there's a couple of separate calculations to work out. First one is the length of u. Now remember, the length of a vector, we square each of the components and add the result. So we've got -1 squared plus 4 squared plus -3 squared. And that gives us the square root of 1 plus 16 plus 9. Well, that's square root of 26. And then the length of v, same type of calculation, -7 squared plus 8 squared plus 5 squared, which is square root of 49 plus 64 plus 25. And to be sure, you would use your calculator for that. It's 113 plus 25, 138. So back to this formula, the cosine of the angle we're after is u dot v dot product, which we know is 24, divided by the product of these two magnitudes, root 26, root 138. And that's a positive quantity, so we know that we will get an angle between 0 and 90 degrees. If this had been negative, we would have got an angle between 90 and 180. Angle between two vectors cannot be greater than 180 degrees. So let's go to our calculator and see how we do this. So we don't use the cosine button. We use on this calculator, so it's a cos, or on yours it's probably cos to the -1. You use a second function button to get to the cos to the -1. So to find theta, I'll be doing the angle whose cosine is, and mine it's a cos theta. Usually we write cos to the -1. The angle whose cosine is 24 over root 26 times root 138. So let's work out first of all on this calculator 24 divided by, and I've got to be very careful what I'm doing here, I'm going to put the whole of the bottom line in brackets. So it's the square root of 26 times the square root of 138. And that whole bottom of the fraction gets put in brackets. So it's 24 divided by the whole of square root of 26 times square root of 138. And we now need to finish off the third bracket, which is a cos. It's a bit more complicated than probably in your calculator, but nevertheless, that's what I do, making sure I'm in degrees if that's what I want. If that was in rads, I'd get the answer in radians. So degree is what I'm going to give it in, and therefore I get 66.38 degrees. And so required angle, the angle that I'm after, is, I'll say 66.4. That's to 3 significant figures of 1 decimal place. And I'll write down the accuracy I've got to 1 decimal place. So that's Mr. Carsey signing out, and thanks for watching this video.